This is the typical workflow that we will follow when developing in the Unreal Engine. We have a C++ to Blueprint workflow where we define some class. So in this case, we have a C++ enemy base class, and that will have some components that will give that class that act as some functionality, such as a capsule for collision, an arrow component which will basically show us which way it's facing forward. It may have some character movement component which allows the character to move around, and of course a mesh, a visual representation. Then in Blueprints we can derive from that C++ class and create specific enemies, maybe with some additional functionality. So Blueprint enemy sniper, for example, or enemy soldier. So we will define the base functionality and the component setup in C++. Then we derive from that and create a Blueprint class. And this makes it easy in Blueprints to then define the base mesh that we want to use for our more specific classes. The sniper's mesh may differ from the mesh of the enemy soldier, for example, and we can set that up in Blueprints instead of hard coding that in C++. And of course that leads to the question, how do we instantiate a component in C++ and how do we attach components in C++? And so we will cover that in this lecture and in upcoming lectures. We won't discuss everything in this video. I've split things up a bit to make the course easier to use as a reference. So in upcoming lectures, we will discuss attachment, that is how we can define the actor component hierarchy or tree in C++. In this lecture, we will focus on how we can allocate a useScene component and assign that as the root component in C++, and then in upcoming lectures, we will see how we can attach a static mesh component either as the root component or to another component such as a scene component, which may be attached to the root component, or that is set as the root component. We will create a new actor to begin this section. In the outline, I will search for dummy actor and delete those from the level. Tools and new C++ class. Choose actor as the parent class and click next. I will give this some silly name, very interesting actor. We will attach some components to this actor in C++. With that set up, I will click to create the class. You may get this file modification detection a pop-up when you create a new C++ class using that wizard in the Unreal Editor. With that, you modify the solution outside of the Visual Studio environment. Typically, if we add our classes from within Visual Studio, the solution will refresh to show those files in our project, right? But since we have modified the solution from outside, that is from the Unreal Editor, we get this pop-up. We can simply click reload to reload the updated solution. If you accidentally click ignore, you can always close the solution and open it up again. That is the .sln file, the solution file, for the changes to reflect. I will close off the dummy actor and the property log component files so that we can focus on the very interesting actor. Back in the editor, I will open up the content drawer and navigate to the C++ classes folder and open the project folder. You may notice that our new class does not show up until the live coding has completed. When we add a new class, the live coding feature will recompile our project. If your class does not show up for some reason, you can close the editor and Ctrl F5 to build and run. In this case, we get the live coding succeeded and our very interesting actor class now shows up. I will drag an instance of that into the level. Notice that the handles do not show up and we don't have a transform section. We want to allocate a component in C++, a useScene component, and maybe in the next lecture a uStaticMesh component, so that the handles show up and so that we get a transform. We want to specify some components such as a uStaticMesh component or a useScene component as the root component for this actor. That is in C++. So that is what we will look at in this lecture. I will actually close the editor for now and save those changes. Back in Visual Studio, in the interface for our new class, in the public section, I will forward declare a pointer to a useScene component and name that root. We cannot call that root component since that property already exists, and we will assign to that shortly. We forward declare these by providing the class keyword, and we do this so that we don't have to include the header for that class in the header file. We typically include those in the source file, and then we allocate the components in the constructor. I would like to note that with some of the components, such as the useScene component and the uStaticMesh component, we actually don't have to forward declare since those come in through the existing includes. I will talk more about this as we go along. I'm just demonstrating it in this way since this is how you would typically do it with a pointer to some type, since that is fine to do with a pointer to a type. With that, you don't have to include the header. We avoid including headers in other headers. When developing in C++, it's best to use the include what you use dependency model, and with that we do not include one header file in another header file if a forward declaration will suffice, because when you include a header file, that header file may include other header files. The dependency grows in that way and can often be avoided by using forward declarations instead, and then we include the necessary headers in the source files where required, and in that way we only include what we use when we actually need that. We've seen some of these examples in the module C++ 102, but I just want to reiterate with that here. I have two examples of forward declarations at the bottom of the slide. In the first one, we have some class entity. We use the class keyword followed by the type and name entity and end that off with a semicolon. That is typically done globally to the file, so not in the body of the class, for example, but preceding the class definition. Then in this way, we can simply do class entity at the top of the file, for example. That is typically following the includes. But in the second example, we have a pointer to an entity, and we forward declare that also using the class keyword. We typically use that syntax where we only have one instance, so we only use that type once, for a reference or for a pointer. I prefer to use the first type of forward declaration, since we often have to pass the type into templates, templated functions, templated pointer managers, and stuff like that. Or, as I mentioned, we may have multiple declarations of pointers or references to the same type. Alright, next, when do we have to include a header that is in a header file or in a source file? Again, we typically try and avoid including header files in other header files, but that's not always possible, especially if you have value parameters, for example, or you want to return by a certain type. So given we have two classes, class A and class B, we must include the header containing the interface of class B. So let's say the class B.h file, the header file, when the class A contains a member variable of type class B, or when the class A contains a member function that returns an object of type class B, so it returns by type of class B. Also when class A contains a member function that has a formal pass by value parameter of type class B. Finally, also when we attempt to access members of class B from class A. So in this case, you might be tempted to add the header of class B in the header of class A, because why not, right? We include the header of class A in the source file of class A anyway, and then the header of class B will come into that anyway. Well, we want to try and avoid that dependency as much as possible. I'll do some illustrations following these slides. The reason why we have to include the header file in the first place is because the compiler needs to know the size of the type that you want to instantiate. It needs to have access to the complete type to lay out the memory required and to compute the memory required for the component instance. For example, we can have some class that has one variable, maybe an integer or a float, or you can have a class that has multiple double members or members of other classes even. So in other words, we can have one class that takes up much more memory to allocate its members than some other class. Again, I have discussed this stuff in the module C++ 102, so you may want to refresh that if you are still having a difficult time with that and with inheritance and all of that sort of stuff. Also, if class B derives from the class A, then the header containing the definition of class B must be included in the header containing the definition of class A. That again will derive from class B, because the compiler needs to know about the full type class B. However, if the definition of class A contains a pointer or a reference that includes members or function parameters to a type class B, then we do not need to include the header for class B. The reason is the size of pointers and references are known by the compiler. When you create a pointer to class B, for example, that is just a pointer that can store the address of a class B type. You are not instantiating a type of class B, you are instantiating a pointer. A simple C++ example using the struct vector here, which is in the player.h file. We have struct vector, which is a forward declaration. Then we have the player class, and in that we have a pointer to a vector. That is a pointer instantiation, and that pointer is going to use the forward declaration just fine. That being said, if you do not have the forward declaration, you will actually get an error. We will have a pointer to a vector. But if you only have a forward declaration, then again, a pointer to that type is fine. However, if you try and instantiate the type itself, so in this case, we do vector location, we get an error because it is an incomplete type. This file where we declare the player class does not know about the vector struct. It is an incomplete type. We are simply forward declaring it. We are not including the header for the vector struct with that definition. The same thing if you want to return by that type. So if you want to return by vector, that is also an incomplete return type. And however, if you have a reference parameter, that is also going to use the forward declaration. The same with the pointer parameter, that is going to use the forward declaration just fine. And then in the player.cpp file, you may assign something to that pointer, or you may use the function print location, for example. Then you want to include the file for the struct vector when you instantiate that vector type, or when you use functions that are defined in that vector struct. Let's look at a simple example using some pseudocode here. To the left, we can see we have some entity header file. That is just for demonstration purposes. That can be any class, it can be a component. Then in the definition of the player pawn, in the player pawn header file, we have a pointer to an entity, or we are trying to instantiate an entity. So we have some entity member, and in this case we are not doing a forward declaration, so we have to include the entity header file, otherwise we'll get an error. Then let's say we have a game mode which keeps track of the scoring and the rules for the game. Let's say for some reason we want a pointer to a player pawn. Maybe we want to fetch the first player pawn and then call some functions on that. Maybe it's game over and you want to disable input on that, or you want to set that pawn to be invisible. Well, again, since we are not forward declaring, we have to include the player pawn. To the right, we can see the sort of representation. As discussed in the module C++102, including a file basically copies and pastes that file. So for the game mode, because we are including the player pawn header, that includes the player pawn header, but it also includes the entity header and the entity header contents. The point of this demonstration is we are not using entity in the game mode header. We do not have a pointer to an entity in the game mode. We are not instantiating entity in the game mode. So it is unnecessary for us to include the entity header in the game mode header. But as you can see from the demonstration on the right, it will be included indirectly because the player pawn header includes the entity header, right? So the game mode file is now filled up with stuff that it does not even need. This is unnecessary and increases your compile times. Instead, we want to use the dependency model include what you use. Here we have the header files and the source files. In the header files for player pawn and game mode, we do the forward declarations, and with that the includes can now move over to the source files, and we only include those when we need those. Again, I'm using some pseudocode here. We actually avoid using new and delete when developing with the Unreal Engine, but this is just for demonstration purposes. So here we can see in the source file for player pawn, we include the header for entity because we are instantiating the entity, and we assign that to the pointer that we have declared in the header file. And again, in the player pawn header file, we simply do the forward declaration for the pointer. And the same thing in the game mode.cpp, we include the player pawn header because we want to allocate an instance of that. So how do we allocate components? Well, to allocate components, we use the following templated helper function. The function returns a pointer to the type argument. We pass in some type, such as RootComponent, for example, and the function is then going to return a pointer to RootComponent in that case. The function also accepts an argument for the name of the new component. The parameter is of type fName. Now remember, the f string is mutable, so we can modify that, but this is a lightweight immutable string, typically used to name objects or assets. For example, we have some demo pointer which will be a pointer to the type argument, and we assign to that whatever that createDefault subobject function is going to return. We pass in the type, the component that we want to allocate, and then for the parameter we pass in a name for the component, and again we will use that text macro. In the source file, in the constructor, we can use that templated helper to allocate the object. We use createDefault subobject, and for the type argument, since we want to specify the object that we want to allocate, in this case a RootComponent, we can then give the component a unique name which will show up in the editor. I will use the text macro and pass in a name. This name is actually often the same as the pointer name that you are going to assign to. So in this case, for example, we have a root. Typically you will have root here for the name as well, but in this case I will change that just for demonstration purposes. So using root, for example, or something like that. Next, we can set the component that we've just allocated as the root component for this actor by assigning that to the root component property. If you have a root component typed out, you can right click on that. You may have to give IntelliSense some time to catch up. and then you can pick definition if you want to see more information on that. It is defined in the actor header file, so it's a property of an actor. It is basically a pointer to a using component, although Epic uses this t-object pointer here, which is used as a replacement for raw pointers in the engine. For example, instead of using a pointer to a using component or a pointer to a uStaticMesh component, you can use t-object pointer that is templated, so you pass in the type in there. I may discuss that further, but for now we will stick to using raw pointers. To set the root component, we can also use the function setRootComponent, which takes in a pointer to a using component, and then we can pass in our root pointer. I will comment that out. That is just for demonstration here. Since we are attempting to instantiate a using component here, using this create default subobject, we need to include the header for the class if it is not already included. For example, the using component lives in the component /scene_component.h file, so the scene component header file. That actually comes in already through the actor include in the header, so we can comment that out. But it's important to note that this is not the case with all components, so do be aware of this. How do we find the include that we need for a specific component? Let's say we know that we want to use the static mesh component, for example, but we don't know what the include is, what include to use for that, or some other components such as the rotating movement component. Of course, one solution is to use the Unreal Engine documentation. I will navigate to the unrealengine.com website. The website may change from time to time, but at the time of recording, we can find the documentation under Learn. Click on the documentation link. In here, I will search for static mesh component. Instead of going through all of those sections on the left, it is even better if you know the exact component name, so uStaticMesh component. Also, if you Google that, one of the first links that come up may be exactly what you need. It may be the link to the documentation page on that. We have some results here, but notice that I can also filter the results in the documentation to C++ API, for example. I will click on the result that is closest to what I think will give me what I want. This one takes me directly to the uStaticMesh component documentation. As I mentioned, it may be best to search for that particular spelling, so just to uStaticMesh component if you know that that is specifically what you are looking for. It may get you to the link that you want a bit faster. At the top of the page, we get a description of the class, and the inheritance hierarchy is right below that, very convenient. We can see a uStaticMesh component. Here's a mesh component, all the way up to uObject. I will control left mouse button click on using component, so we can look at that as well. Scroll down a bit and notice that in the references section, we have what we are looking for here, the include. We can include the components static mesh component header. Same thing with the using component. We have the inheritance hierarchy and the include. You also typically have a remark section which describes the class, in this case a component. The rest of the page will detail the members of the class. This is just an example. We actually don't need to use the includes for the uStaticMesh component nor for the using component, as those typically come in through existing includes. Those are commonly used components. I'm just using these components as examples since we will be using those in this section. But let's say you need the include for some other component, such as the rotating movement component. You may get a compiler error when you try and allocate that component or call functions on that component. So we can head over to the documentation to see what the include is in the references section right here. Here's an example with the rotating movement component. Let's say we have some actor, in this case demo actor. We will actually allocate in the source file in the constructor. So in the header file, we will have some pointer, a pointer to a rotating movement component, and we can forward declare that using the class keyword. We can also forward declare that globally, doing class followed by the type, so in this case rotating movement component, ending that off with a semicolon as we have seen. But in this case, for example, this class will only have one of those pointers. Because of that, we can use this syntax in the header. Then in the source file, we will go and use that create default subobject helper and then pass in the type. Of course, we also have to pass in the text macro and pass in the name for the component. Because we allocate in the source file, we include the rotating movement component.h, which is in the game framework. Alright, and I just demonstrated where we can find that. We won't actually be using this component in this demonstration. This is just a demonstration of how you would go about finding the include for a component where you actually do need to include the header. A quick demonstration on why we don't need to include some of those components. Remember that our actor derives from the aActor class. Because of this, we have to include the actor header file in this header file. Now if we navigate to the actor header file, we can see that derives from the uObject class, but also that it includes a bunch of files of its own at the top of the file here. The actor header includes this header, the child actor component header. As a tip, you can search the Solution Explorer to find those files. As we can see here, the child actor component header file includes the scene component header. That is why we don't have to include it when we derive from the aActor class. Now we can include that again if we want, if IntelliSense gives us a hard time, since your headers have the include guards, in this case the pragma ones. Also notice an example of a forward declaration in this file. It forward declares the aActor class. Back in Visual Studio, I will build a run so that we can see what we get. Search for our very interesting actor in the outliner and select that. With the instance selected, the handles now show up, and we can also modify the transform, which as we can see now also shows up. But if we select the root component, we get a strange warning. Native, meaning C++, components are editable when declared as F property. Basically, we need to decorate that property, the pointer, with the uProperty macro. Notice the fields are grayed out. Back in the header file, I will decorate that with the uProperty macro and pass in visible anywhere. Remember, this is a pointer. We don't want to modify, or in other words edit what the pointer is pointing at least not in this instance. So I will provide the visible anywhere specifier. Save those changes and recompile. Now with the root component selected, we can modify those transform fields such as the location. Also notice that our component name shows up in here that we specified in C++. Don't let the red billboard confuse you. Our actor actually does not currently have any visual representation, not even a billboard like a light might have, for example. To wrap up this lecture, a summary on what we've learned on the root component attachment. The root component is an aActor property that defines the transform, so the location, rotation, and scale of the actor in the world. We have the syntax is basically a pointer to a using component or a t-object pointer, passing in the using component. All other components must be attached to the actor's root component somehow. We've seen some examples on how we can attach a using component to the root component. Let's say we have some pointer to a using component named root. Then we can assign to the root component property directly, or we can call a function setRootComponent and then pass in that pointer name into that function. In the next lecture, we will see one more way of doing the attachment and also where we can attach other components, that is multiple components to each other to set up a sort of tree. And we'll also see how we can allocate a static mesh component.